Now let's focus on the nomenclature of the alkenes. And alkenes, there's a specific thing you have to know when it comes to the alkene. They are sp2. They are what? A double bond. They are what? Unsaturated. They are what? Unsaturated. Do you understand? So that what you need to know here. sp2 double bond. They are what? Unsaturated. So whenever you see a double bond, a double bond organic compound is an alkene. So how do you name alkenes? What you want to understand here is that the nomenclature of the alkenes follows that of the alkenes. So if you have mastered the nomenclature of the alkenes, the nomenclature of the alkenes will be a little bit easier for you. Just and so in this video here, I'm going to walk you through all the rules for what naming what alkenes. Then in my subsequent video, we are going to name complex one. Do you understand? So now alkenes are derived from the alkanes. So when we talk about alkanes, now the AN is changed to what? ENE. Do you understand? So the first members of the alkene is not ethene, is what? Ethene. So we have what we call ethene, propene, butene, butene. Here we have pentene, hexene, heptene, nonene, and what? Decene. Right there. Now, alkanes have general molecular formula, and the general molecular formula of the alkanes is what? CnH2n. This is that CnH2n. Remember, the general molecular formula of the alkane is what? CnH2n plus 2, right? So remember, H means 2 carbonatom, 2 carbonatom, 3 carbonatom, 4 carbonatom to what? 10 carbonatom. From here now you can get what the general the molecular formula for each of the what of the compound here. So remember, N means what? Numbers of carbonatom. So it means first 2 carbonatom each. So whenever I see it means what? 2 carbonatom. Whenever I see pro means what? 3 carbonatom. Whenever I see brute is what? 4 carbonatom. Whenever I see pent, 5 carbonatom. Whenever I see eggs, 6 carbonatom. Whenever I see pent means what? 7 carbonatom. Whenever I see non means what? 9 carbonatom. Whenever I see deck means what? 10 carbonatom. Do you understand? So what putting the numbers of carbonatom here to get each of our general molecular formula. So if you should put 2 here, it's going to be C2H22, right? Now going to be C2H4. So the molecular formula for it is what? C2H4. If you should put 3 here, it's going to be C2H6. If you put 4 here, it's going to be what? C3H6, C4H8. You're going to be C5H10. You're going to be what? C6H12, right? Here are what? C7H14. Here are what? C8H18. Here are what? C9. 2, 3, 4, 5, 6, 7, 8. Oh yeah, you have octane. Sorry, I skipped one. Octane, which was C8H18, CH16. Here we have what? Nonene, which was C9H18. Then here we have decene. Decene, which was C10H20. So there are things you need to know for the first 10 members of the alkenes. You get. So as we move on, I'll be showing you how to draw that structure. But then let's to what rules for what naming alkenes. What are the rules for what naming alkenes? What are the rules for what naming alkenes? Now, rule number 1: the longest continuous chain containing the functional group that is carbon-carbon double bond is number in the direction that gives the functional group the lowest possible number. So in the sense that in the rule number 1, you have to what? Take the longest continuous carbon chain that carry what the functional group, which was double bonds, and number it in a way in the direction that the double bond must have what lowest possible number. I will explain that to you. So if for example here we have CH2 double bond CH, CH2, CH2, and what CH2, right? Now here we have how many carbons do we have? 1, 2, 3, 4, 5, right? 5. Now, because here we have 5 carbons here, it's going to be what? Pentene, right? Pentene. Pentene. That is it. Because there's a double bond here. So now, what we want to understand here is that the double bond must have the lowest possible number. If you check what the nomenclature of the alkenes, now alkenes do not have a functional group, right? Both have the functional group here. So what we want to understand here is that we must number it in a way the carbon atom that carry the functional group must have the lowest possible number. So we can either start our number from here, or we can start our number from here. If I start my number from here, here I have 1, 2, 3, 4, 5, right? But I start my number from here 1, 2, 3, 4, 5. So what I want to understand here is that now if I start from here, the carbon atom that carry double bond is what is 4. Just that is 4. When I start from here, the carbon atom that carry the double bond is 1. So it is saying that you must number in such a way that the carbon atom carry the functional group must have the lowest possible number, which is double bond. You get? So if I start from here, I'm going to have 4 pentene. Right there. That is pentene, that is it carry a double bond, but the double bond is carried by what? 4. But when I start from here, you're going to be what? 1 pentene. Just now, which is going to be the correct one? Of course, 1 pentene is going to be the correct one. Just so now, whenever you are naming here, the first one to do here is what? Take the longest continuous carbon chain that carries what the double bonds and number the chain in a way the double bond must have what lowest possible what number, as easy as that, irrespective of what of the numbers of what of the substrate attached to it. So it is saying that this one is correct one, this is the correct one, this one is the wrong one. Now, but we can write this one again to be pent, or it can be pent 1 in, pent what? Pent 1 in. So it can either be 1 pent or pent 1 in. You see that? So any of it correct. So that's what rule number 1. But now let's do more. If for example here I have something like this, let me draw skeletal structure. Let me draw skeletal structure here. So now what will be the parent chain? Now if I remember here I have something like this here, what will be the parent chain? Remember I have my double bond here, right? Right, I have my double bond here. So instead I must number it in a way it must include what the double bonds. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, so from here to here we have 10 that carry double bond here. So it's going to be decene, right? But what is the position of the double bonds? What is the position of this double bond here? Now remember, if I start from here, 1, 2, 3, 4, 5, 6, 7. Carbon 7 is carry what double bond here. So going to be what? 7 decene, or dec 7 in, or you can say dec 7 what in, or you can say dec 7 in, right? So that when I start my name from here, 1, 2, 3, 4, 5, 6, 7, right? But when I start my name from here, 1, 2, 3, going to be what? 3 decene, right? Or dec 3 what in. So to you now, which one is the correct one? This is the correct one, as easy as that. So now what you want to put in your mind is that when you're naming alkenes, the first thing you want to do here is to take what the longest continuous carbon chain that include what double bonds and number it in a way that the carbon atom or double bond must have the lowest possible number. So that's what first thing. If you can get this first thing right, then you have solved majority of over 6 to 7% of the problem. Just so the next thing is what place what the substrates. So let's move to what rule number 2. Rule number 2 state that if substrates are attached to the parent chain, the substituents are arranged in alphabetical order. So, for example, here, let's take this one here. Let's take CH2 double bond CH